Hello guys, this Science of Sport video is part of videos for BTEC Sport and Exercise Sciences, Unit 2 Functional Anatomy. It's particularly focusing on Learning Aim F, the analysis of the skeletal and the muscular systems and how they work together to produce movements for us. This is part 4 and in particular looks at movement efficiency. So the specification for the F section is sort of titled Inter-relationship of the muscular and skeletal systems in movement analysis. So clearly from that title it's about how these two systems integrate and work together to allow us to perform the skills that we do and the exercises that we do. Now this specific video is looking at movement efficiency. Now some of the others are a bit more almost nuts and bolts of the systems. What are the joints? What are the bones? What are the names of the muscles? This is more to do with how we execute skills effectively, efficiently to produce big forces that we apply on the balls that we kick or the balls that we hit or, throw. So it's more to do with the execution of skills rather than purely the actual nuts and bolts of movement. One thing worth noting going into this video is that for your question 12 in your exam paper, which requires you to analyse the skeletal and muscular systems related to a particular movement, this topic is very much your icing information. This is the sort of content that will get you hopefully to the level 3 standard, the higher grades. So without this, you may not achieve that highest grade. So it's really important that you get your head around that, most of these, some of these, to be able to offer that to your answer. So we can see that there are 6 different types of characteristic or factor to just appreciate in terms of efficient movements. So let's have a look at them one by one. First of all then, static and dynamic balance. So the gymnast here is demonstrating static balance. They're able to remain stable or controlled, balancing their centre of mass over this small base of support on the ground here. That is static balance. And obviously in certain sports like gymnastics or dance, this sort of balance is really important and requires muscles to work isometrically to stabilise joints to keep you in position. However, many of our sports require dynamic balance. Many of our sports are active, dynamic, moving into, moving out of, or moving while executing the skills. So tennis is a nice example. Often shots are played on the run. Often the athlete is required to move and demonstrate agility, changing position, remaining balanced and in control of their body, managing their body. So that we should know to execute a skill, for example, this forehand topspin shot, we've got some prime movers, some agonists that actually make the action happen. So pectoralis major maybe, anterior deltoid, and the sort of abduction element of it, middle deltoid. However, we've also got some core muscles. So the internal obliques, transverse abdominis is another core muscle that act as stabilizers or fixators. They are contracting to keep this trunk section stabilized, controlled and balanced to support the athlete transferring force from their strong leg muscles pushing off the ground to transfer the energy and the force through the body and up to the racket. So dynamic balance is a really important aspect of a lot of the sports where we're required to be moving whilst playing certain skills. So dynamic balance is the platform for other skills. It's what allows us to play other skills whilst being active, whilst moving. So I want to play a very short little video clip of a tennis coach talking about the importance of dynamic balance and dynamic stability in tennis.
Balance can be defined as the ability to maintain body equilibrium where all force couples equal 0, meaning they cancel each other out. You can think of it as static equilibrium. On the other hand, stability can be defined as the ability of an object to maintain body equilibrium while in motion. It can be thought of as dynamic equilibrium or dynamic balance. Balance and stability training are training components to improve speed economy and agility. On the one hand, speed economy improvements assure that minimal excess energy is expended or wasted to perform the athletic movement, and on the other hand, agility improvements allow the athlete to change direction more effectively. Stability training allows for better agility by establishing force and counter force couples, but oftentimes people think of balance training as the attempt of someone to hold a steady position, which is a state of static equilibrium and all force couples equal zero. While playing tennis, the athlete is almost always in motion and hence needs to deal with stability, maintaining dynamic equilibrium. During dynamic equilibrium, all force couples are controlled to a point of stability. The force couples don't have to be equal to zero, which is where the athlete is completely static, but the differential has to be small enough that the athlete can control the center of mass within the base of support to maintain stability. Since agility can be defined as the ability to change direction, it is obvious that maintaining stability during directional change depends on how well the athlete can manage his or her body and maintain stability. In addition, stability training affects performance because the athlete needs to be in control or stable during stroke production. That explains why agility and stability training are directly related to each other and why an athlete needs to have good balance and dynamic stability capabilities in order to change direction on the court effectively and improve overall performance. The relationship between prime mover and stabilizer strength is important because athletes are only as strong as their weakest link. For example, if an athlete squats 250 pounds using a Smith machine, then the 250 pounds will not translate into the squat because the stabilizers will fatigue and the force needed to lift the resistance of the legs cannot be transferred effectively. In other words, athletes often will not have the stabilizer strength, which is the disconnection between prime mover strength and energy transfer in force application. So there might be an athlete that can do heavy squat or bench presses, but they don't perform as well on the court as the athlete that can do power cleans very well. Therefore, total force production, meaning how strong the athlete is less important with respect to performance than how well the athlete can manage his or her body weight. Therefore, we also use balance and stability training to enhance stabilizer strength, to maximize energy transfer and hence athletic capabilities.
Okay, so hopefully you appreciate that static balance is really important. Having stabilizing muscles that can maintain a still position matters for certain activities or events, but actually dynamic balance, having fixator muscles that can isometrically contract, and if in doubt, talk about core muscles, talk about obliques, stabilize our trunk to enable us to execute skills effectively and generate forces through our prime movers. Okay, so the second and third characteristic or factor relating to movement efficiency are kinetic chain and transfer of movement across body segments. The reason I've put these two on the same slide together is because I think they're really related. It's harder to completely separate them. Let me talk about kinetic chain to start off with. So basically, if we look at this graph here, this is of somebody, they're either throwing a ball or bowling, but that sort of throw action. What it illustrates is that over time, from the start of the skill to the end of the skill, you can see that each segment of the body, so legs, trunk and back, shoulder, elbow, wrist, are activated to generate force. They don't all work at the same time. They work sequentially or in series, one after the other, obviously with a little bit of overlap. So a lot of the movements that we have involve our body working bit by bit by bit by bit in a series or in a sequence or in a chain reaction. So think about chain reaction for this one. Kinetic is movement, so it's a movement chain reaction. Our foot placement, our leg action, our trunk action, our shoulder action, our elbow action, our wrist action. Again, I'm just going to show you a very short video of a tennis coach explaining kinetic chain relating to tennis.
Today I want to talk to you about the kinetic chain. The kinetic chain is extremely important in tennis, and I'm sure most of you have heard about the term. So what exactly is the kinetic chain? In tennis, power is generated through the different body parts working together. Essentially, your body works as a linkage system where energy is transferred from one link to the other. The kinetic chain is also the reason why tennis players don't need huge muscles to hit the ball very hard. So what exactly does the kinetic chain look like? I'm going to take the forehand as an example to demonstrate the kinetic chain. The principles involved are the same though for any stroke. Basically, you want to coil and uncoil all of the body segments that are involved. Your muscles work like a rubber band in this process. They get stretched, energy gets stored, and then transferred to the next element of the kinetic chain. So, on a forehand, it all starts with the legs. They coil and uncoil. The energy gets transferred to the hips, through the core, and into the arm. In order to maximize your potential on any stroke, you need to involve all of the body segments in the kinetic chain. Now, when analyzing someone's stroke, I always look for problems in the kinetic chain first. Most recreational players use only parts of the kinetic chain. A very common problem is hitting with the arm and not involving the lower body. Let's go ahead and compare two forehands, one with good use of the kinetic chain and one where the kinetic chain is not used properly. What you can see here is that on the left, I'm really turning my shoulders and coiling my upper body. The legs are also very bent and a lot of energy is stored. On the right, on the other hand, I barely turned the upper body, the hips are not coiled, and the legs are barely bent. Now on the left, all of that energy is going to be transferred into the shot, whereas on the right, the energy comes almost entirely from the arm. Now have a look at the whole sequence one more time and compare the correct motion to the incorrect motion. Alright, so much on the kinetic chain. It is essential that you make good use of the kinetic chain in order to get effortless power on your strokes.
So that little video clip demonstrated visually, I think, with the example of the correct and the incorrect technique, how important actually the legs and the lower body are in generating force for the rest of the body to actually transmit through often our arms. The poor performer was hitting purely with their arms, their shoulder, and the correct technique on the left showed the leg action leading into, coiling and then uncoiling to produce energy that moved through this kinetic chain. So really importantly, the kinetic chain is generating movement through a series of joint movements from often our lower limbs eventually to our upper limbs, and then onto the ball, the racket, whatever it is. And again, the second bit of information here, or the second factor I've put on here, transfer of movement across body segments, actually is quite similar to kinetic chain. It says the skills require interaction of body segments, coordination and energy transfer. So a tennis serve, in a way, this is illustrating the different muscles, the different joints, the different body segments, the lower body, the trunk, and then the arms, generating force, passing force through each segment, eventually going through the racket into the ball. So I think you can quite easily remember those two together. They're actually fairly similar. The next one actually I sort of find similar again, but I decided to separate it, perhaps because the golf swing is an example. Several sports, so if you look at the golf example here, we start with weight on the back foot, transferring onto the front foot. So the load of the body is on the back foot, and then the load of the body is through the front foot. If you think about a tennis forehand, Often the load starts on the back foot and goes through into the front foot. Hockey, striking the ball, hitting the ball, pushing the ball in hockey. Weight is transferred or load is transferred. Force is transferred from the back foot to the front foot. You build momentum by transferring load from one foot to the other. It's also a little bit protective, spreading the load over the 2 points of contact, but it illustrates really this movement of weight from one side to the other side, building up force through the body. So there are several examples really that could relate to that, transferring loads and building up force through the body. Next example is quite easy to explain through athletics. So one of the most common injuries for sprint athletes is a torn hamstring. So they obviously are rapidly trying to contract their quadriceps to straighten their legs, to place it on the ground, and then pull on the ground to project them forwards. We typically have slightly bigger, stronger quadricep muscles than hamstring muscles, and because these contractions in a sprint are so explosive and so rapid, it's not uncommon that sometimes the quads are stronger than the hamstrings, and therefore the hamstrings can't cope with the big forces the quadriceps generate, and as we straighten our leg rapidly, the hamstrings get torn. And that's because we have muscle imbalances. So it's incredibly important for all over the body, not just legs of course, but all over the body. You know that we have typically muscle pairs, muscles or muscle groups that work with each other, one on one side of the body or one side of a joint, one on the other side of a joint. Therefore, in order to maintain muscle balance and avoid injury in particular, but also to equalize performance, we need to train both antagonistic pairs. Not just do, your quads, make sure you do equally your hamstrings. Not just do your pectorals. A lot of people might go to the gym and, try to get big pec muscles, chest muscles, and then not do enough trapezius, rhomboid training on your back to balance the two muscle groups. If you do too much chest exercise and not enough back exercise, you ended up having sort of rounded, protracted shoulders because those back muscles aren't strong enough to keep your shoulders pulled back. So it's really, really important. Again, often people do a lot of sit-ups because they want six-pack, or want strong abdominal muscles, and then don't do enough erector spinae muscles or gluteus maximus muscles to really strengthen the buttocks and the lumbar area, your back. And therefore we have muscle imbalances, we have a strong front, we have a strong anterior, we have a weak posterior body. And that's when we get things like backaches and back problems. So training muscles in pairs, really, really important. Okay, so the last of these 6 factors that might affect movement efficiency is mechanical efficiency. Mechanics are literally the ways in which we mechanically move. And mechanical efficiency refers to the ratio of work output to work input during the activity that we're doing. So how much effort do we put into moving the way we move? And obviously to be efficient, or to be mechanically efficient, we want to be able to move with the least effort, the least energy expenditure, as we can. We want to not waste energy doing the movements that we're doing. Now I can't resist myself. I'm going to show you one little very short clip from Friends, the sitcom, just because it illustrates inefficient mechanical movement perfectly.
I have to tie my shoe, so you go ahead, I'll catch up. Okay. Come on, let's go, Riley, let's go!
So Phoebe in that clip obviously demonstrated perfect, ineffective, inefficient running technique. She had a very strange leg action going very wide. She was jumping up and down effectively when she was running. All of that basically wasted effort, energy, and that's lost. She will undoubtedly fatigue more quickly than Rachel with a more conservative, more efficient, mechanically efficient technique. So this would be applicable to, all sorts of sports, but just having shown you the Phoebe's running technique, I just want to again show you a very short clip on Mo Farah, obviously one of our elite, successful distance running athletes. And it would be incredibly important for Mo Farah, who does, 10,000 metres or marathon events, not to waste energy, A, because of fatigue, but also because it will slow him down.
Now, not just without overstriding, he's also managing to do so without particularly expending too much energy up and down. So if we drew a line in parallel with the track here, so if we drew a line here, and we'll just let this run through, there's very little unnecessary vertical displacement. Of course, Mo is going up and down, and you need to be able to cover the ground stride by stride. But actually, if we look at how steady his head is as we go through this, steady as head is, steady as hips are, we don't see the same kind of uncontrolled bouncing as we see from so many of our overstriding, plodding kind of recreational runners. So again, that's a function of high cadence. So Mo's running kind of low 180s here as he's turning his legs over very quickly, and not overstriding, not expending excessive energy braking with each stride. He's landing efficiently underneath that flexing knee, allowing him to maximize the propulsive force, then pushing off rather than dealing in excessive braking to begin with. Of course, Mo's torso is very upright. Okay, there is a gentle forward lean, but I would expect that forward lean as a function of the pace that he's running at, rather than something he's consciously trying to force. Okay, what we do see is the relaxed nature of the shoulders. Okay, short lever of the arms, so we can see that the arms are maintaining this sub 90 degree angle at the elbow the whole way through, and he's managing to, here we go, it's a better view, and he's managing just to drive the elbow back, back, back with each stride, relaxed from the shoulder, creating this nice, efficient, gentle sway that is so characteristic of Mo's running style.
Okay, so what that video of Mo showed was two things really. Firstly, he doesn't waste energy with his running technique with lots of vertical movements. He needs to move horizontally as fast as possible and as efficiently as possible without wasting energy. Some runners you see are very much sort of run on their toes and they're springy and they travel up and down, wasted. The other point that the analyst made was that he said his elbows are sub 90 degrees, so he's got quite tight arms, if you like. They're not down by his side, they're tucked up. That means that the forward and back movement is very, very efficient. It's very, very mechanical. They don't rotate in the transverse plane across his body, because that rotation is wasted energy and it's counterproductive for moving forwards. So everything should be in the sagittal plane to be efficient, mechanically efficient, and trying to propel yourself forwards. So just before I move on, the other example I thought was pretty easy to understand was swimming technique. So sometimes you see people in the swimming baths and they're doing front crawl and they don't just tilt their head to the side to breathe, they lift their head right out. Now when they do that, their body position rotates completely. It's very biomechanically inefficient. They're changing their body position. Sometimes they are immobile in the shoulders and they twist too much. Sometimes they haven't got good leg kick and their legs drop down, which means that they're trying to go through the water, not like this, like a submarine, very streamlined, but like almost like a sinking submarine at one end. And all of that frontal surface is having to be pushed through the water. It's not efficient at all and takes a lot more energy. So technique and minimizing wastage of energy is all about mechanical efficiency. So this slide really just goes through the 6 different movement efficiency factors that I have mentioned with the sort of very abbreviated key phrases. I suggest you get your head around at least 3 of them, if not more, for the question 12 analysis. I just want to finish with a couple of slides. Firstly, one, going through an example. Now, I'm not going to read this all out. I'd like you to pause the video and go through it. What we've got here is each of the characteristics with the sort of description and then a bowling related application of it. So what it might mean to this bowler here. So each of the 6 things is in sort of blue and then the cricket application is in red. Please pause the video and have a read through that. Just again to realise that these movement efficiency factors relate to so many of the different sports that we play. The kinetic chain, the transfer of load, the transfer of force, weight transfer goes from back foot to front foot in all of these sports. Kinetic chain, or moving force from one section of the body to eventually the limb, one section of the body to eventually the ball, one section of the body to the arm, relate to everything. Having imbalances, so if you're a right-sided player, making sure you still train your left side. If you're working one muscle group, so the triceps brachii for power and extension of the arm, making sure you work the biceps too. Lastly then, just something to try and maybe assist with the actual, how are you going to get this sort of information into your question 12? And I might reiterate this in another video purely on question 12, but these were some of my thoughts. So these are our 6 things. It could be as a way of remembering them, that you just remember these words. Know the stuff well enough that with these 6 words you could understand what we mean. And then these could be the phrases that the sorts of phrases that you use to put in your paragraphs when you're doing your question 12 muscular skeletal analysis. Again, pause the video, have a read of those, but I might well mention these again in the question 12 how to write a question 12 answer video.